Hello again everybody, hope you're doing well and thanks for joining us for another video. Now, flat earthers repeatedly claim things like there's no space, there's no ISS or satellites, there's no true photographs of Earth, that they're all just CGI renders, and one aspect of this that regularly gets brought up is questioning where are all the satellites and space debris in the ISS footage.
On the bottom here, those are the claim satellites. On the right side are the really big ones, the football field sized ones. So you should be able to see all of those, especially on a 24-hour time lapse. Now on the left are the total amount of satellites and space debris. So you'd also be able, now obviously you wouldn't be able to see the space debris that's really far. But out of the thousands, tens of thousands, or even hundreds of thousands, or even millions of pieces of space debris, any of the little pieces of space debris that were flying by the camera over a 24-hour time lapse, or even a 12 or 6-hour time lapse, there would be dozens, if not hundreds, if not thousands, that would fly very close to the camera that you would clearly be able to see regardless of exposure settings.
As of October 2023, there was said to be over 7,700 active satellites, along with 3,300 inactive ones, for a total of about 11,000 satellites orbiting Earth. The European Space Agency published figures in 2022 saying that there are almost 33,000 objects in space being tracked by the CFSCC, but that their models estimate that actually there's probably more like 36,500 objects that are larger than 10 centimeters and millions that are smaller than that. And so it's argued if the footage from the ISS was real, then we should be able to see all of this. And when you look at the debris tracking models, it looks like you can't move in space for the junk that's floating around Earth. So why does none of it hit the ISS? Much of this all comes down to a need to appreciate relative sizes as well as probability of debris hitting the ISS. Interestingly, it has. In May 2021, the crew on board at the time noticed that a hole had been punched through the large robotic arm. However, the ISS can avoid known debris. Pretty much all the big pieces of debris and satellites are tracked, and they're sitting in pretty predictable orbits. So if and when there is a chance of debris intersecting with the space station, it will be known about ahead of time, and it can be reacted to. Back in 2007, the Chinese tested one of their anti-satellite missiles by blowing up their Fenghuin satellite, which left over 3,000 pieces of debris. In 2021, the ISS had to make an orbital adjustment to avoid some of this debris. They used the rocket engine of a Russian supply craft that was docked with it at the time to raise its orbit by more than a kilometer. In the 20-odd years that the ISS has been in orbit, it's had to do around 30 such maneuvers to avoid debris. Funnily enough, the problem of space debris isn't only a problem for things in space. In 2021, a pallet of used batteries were jettisoned from the space station. They were intended to be returned to Earth on a Japanese cargo craft, but that had to depart before the pallet was ready to go, so the crew had to jettison the pallet into space, where it would slowly degrade in orbit and burn up in the atmosphere, which actually happened just a few weeks ago. The ESA reported about the batteries on their website on March 8, 2024, just a few hours before they re-entered the atmosphere. Most of the pallet did indeed burn up in the atmosphere, however, it seems a portion of one of the batteries found its way back to Earth, straight through the roof and 2 floors of a house in Florida. Now, of course, the question for flat earthers is, where did that come from? For a relatively small piece of metal to punch its way through an entire house requires a lot of speed. Just consider a cannon. I doubt dropping a piece that big from an aeroplane would create sufficient speed to punch its way through a whole house. Anyway, let's get onto the claims about not seeing any of this. Ultimately, it boils down to scale. When you look at the charts showing satellites and space debris, it looks like they completely cover Earth. In reality, though, those objects are nowhere near that relative size compared to Earth. The ISS is the largest man-made object in space. It has a maximum diameter of 110 meters, about the size of a football field. The Earth has a diameter of 12.7 million meters. meaning you would need more than 115,000 space stations placed side by side just to cover the diameter of a two-dimensional Earth. Now time to get really mind-blowing. The ISS is 110 meters by 74, so it has a footprint of 8,140 square meters and an average orbital height of 408 kilometers. Earth has a radius of 6,371 kilometers, so if we add the 408 kilometer altitude of the ISS, that puts the radius from Earth's center to the ISS at 6,779 kilometers. The formula for the surface area of a sphere is 4 pi r squared, so at the altitude of the ISS, the total area above Earth that it would cover would be 577 trillion square meters, meaning you would need more than 70 billion space stations all parked next to each other to completely envelop the Earth. There are only 11,000 satellites, and those are much smaller than the ISS. Despite Mindshot claiming that they're the size of football fields,
those are the claimed satellites. On the right side are the really big ones, the football field-sized ones.
That is not the case. The ISS is the size of a football field, satellites have an average size equal to that of a pickup truck, and space debris, by comparison, we're talking sizes measured in centimeters. So for the most part, we're dealing with relatively small objects. Even if you were to take every satellite and every piece of space debris around Earth and place them all side by side, you could not completely cover the Earth the way that those trackers depict, because those objects aren't the size of small islands like those trackers depict. Just consider we're talking about 11,000 satellites here with an average size of a car surrounding the entire Earth. A recent report from the Metropolitan Transport Authority says that Lower Manhattan sees around 900,000 cars every day. That's more than 80 times more cars than there are satellites, and yet even then, the cars and trucks don't completely cover Manhattan Island. I mean, just take flight radar, for example. When you zoom out, you can't see most of Europe for planes. On average, there are more than 8,000 commercial planes in the air at any one time around Earth. Now, commercial planes are much larger than satellites, and those figures don't even include the private and military planes, and yet, unless you live fairly close to an airport, you could probably count on one hand the number of planes that you can see at any one time. And if they're at cruising altitude, you're unlikely to immediately notice the plane itself. You're more likely to see those trails of dihydrogen monoxide that are spewing out the back of them. If those contrails weren't there, you could easily miss that the plane was even there in the first place. And not only are those planes multiple times larger than satellites, but most of them are within a region of 12 kilometers above you. Earth's low orbit is generally in the region of 300 kilometers to 2,000 in altitude. That's a window 140 times taller than planes fly. We can generally see planes of a distance of 100 or 200 kilometers away. From the ISS, the horizon is more than 2,000 kilometers away. So you're looking at millions of square kilometers of empty space trying to see an object that is the size of a pickup truck at best. You struggle to see a pickup truck from a plane 20 kilometers away. And that links us back to the earlier topic about avoiding debris. The large pieces of debris that would cause the most risk to the ISS are tracked and are moving through a volume of space many times larger than the area which planes fly through, and yet air traffic controllers can easily see when planes are likely to get close to each other and adjust accordingly to keep them a safe distance from each other. Now, as I said, when spotting planes off in the distance, you usually don't see the plane itself. You see the contrail first, and then you work your way along to find where the plane is. Without said contrails, the plane itself is very difficult to spot. However, as I covered in a recent video, around sunrise or sunset, you can often see sunlight glistening off the bottom of the plane. And that reflected sunlight can be very bright and easily noticeable. Well, in most examples of the ISS footage that flat earthers use to show apparently there's no satellites, it's pretty much always either broad daylight looking against a bright Earth, or in the middle of the night when the satellites would be in Earth's shadow. When we look at the night sky and we see satellites, They look just like stars that are moving. Well, during daylight footage on the ISS, the camera is exposed such that it's not even picking up stars, so we wouldn't really expect to see any satellites or space debris here. If you look at footage from the ISS as it approaches sunrise, you can regularly catch satellites ahead of it as they are coming into view of the sun. So we can see satellites from the ISS, but when you consider the sheer volume of space that they can reside in, and them being about the size of a car, it's little wonder that we struggle to see them most of the time, given that when you're on board an aeroplane, you can rarely see other aeroplanes. We might have half a chance of seeing satellites on the ISS footage if they had contrails coming out the back of them, and we're only likely to see satellites which are orbiting around the same altitude as the space station. Geostationary satellites, for example, wouldn't necessarily be too far away to see, but because their orbits are matching Earth's rotation, then from the view of the ISS, which is completing an orbit every 90 minutes, any geostationary satellites in view would not appear to move much more than the stars around them, and so from the ISS, it would seem like they are just stars in the footage. We can, however, capture geostationary satellites from Earth. If you view long exposures of the night sky that are taken looking towards the sky above the equator, you can often see that whilst all the stars are trailing as you'd expect, you'll find some spots that are staying in exactly the same place on the camera. Those are geostationary satellites. So that's going to be it for this video. As always, feel free to leave your thoughts in the comments below. If you enjoyed this video and you haven't already done so, then please consider hitting the like and subscribe button, and then hopefully we'll see you in the next video.